Skole ngambulo luku. With whatever we do. Jioni safu nola. With whatever we do. Hale yidemu new school. Nyepamne nekudlukula. Nyepangiragala gena. Nyepamne nekudlukula. Ibuloke nongoto ni beti sola. Ibuloke ndato ni betoto.
Mingi Congo. Na?
Lami te jibe norin te nyame lamin.
Kabona wulo kono.
Wulo kono nyinta mo lamin.
Pabilenki.
Muna ngata afongole.
Haina.
Ngata. Ngoto le. Fabrama.
Mingi. Baba nyola.
Ngoto le Fabrama.
Namu jumara kan kuma diten.
Fabrama.
Jumara mu.
Ndele bare muso.
Nunda mana.
Kamo kata.
Jamani mbere.
Alindo ko.
Jamani.
Bari ngoto mon kontande.
Bari jamani fana na mundu ma mon kontan.
Ngoto minaka ngala min je fon filitala. Lamin jibe nori nyala.
Lamin ila siran sama ne benki. Yala so tol sayni no ko ngol ko momo.
Ngoto.
Nam.
Itedinte yalo ne lamin hakilo diata bake karamungoto. Anu santeng ministry ko di ngole suoko na amanke ko do holiday
si bitun
Bagona ringa.
ala ni ko de namo balo
ala ni na ko na karta bulo be dam ala ni je
ngoto
nam
ngoto mon kontan fere
jamani mu ne keda
ite ka lamin ki wulo ko no nyintay mon ko do fete malo lamin nyande sila la be la moy kala karango
jamani karamol be soron ne ko fasita wulo ko no ko
karamol ma ko ni ko karamol soron da amanke ko holiday lem ngoto dini wo nyanta sila la ala karango la moy yamen kamen fue man kontan andamande
alla nyin kombo courant adanda la kombo len do la jankara mol soron da do kamen courant ma do la kombo e don dol fana na kara mol soron je kara mol soron lamin adara lo nyino la man tara fe na sokon ala mu nekela
ama lamin ite fete malon ko lesinol be ke kar radio to
Nga fine.
e ko nyani mo lamin
Nga fine.
ya mu na fonye
kabin mina kan tambita nteri maning fatu tambite la sukala ala dinngol bebe siri be la moy ka
faru dan so am fana tambita jele ni subala la ngaje dinngol be jet talanta nen kili warol e be seri jele
sa lamin fadante ku kili wo ke no la ba lamin bitaka wulo ko no nyinta mo alami
aman dara fenela
ite dine ko ni man si yakari la suno la moy radio to balon na
mu ne ka ke afonye ba nyara ni alon
telentel jikot
afonye ba mu de be ke
ite balon tel be jikritel ni man karambe ku kele yaje nata karana mbasa mala ya etarije
par ñarande kombo courant ho findira kombo ide na rajede ni sonka bay ko lamin manya tala wulo ko kara mo be so dafa nyembe
ko to wole nati bayo ngalle ni lamin kuntala kombo courant o ka fa me kombo courant asototal wala kinay ko e sisu ko no bari ni ko e sisu ko no be karangol dike la radio lin telel to hani tele masoto to nyaay man tele soto la bungo bar radio be bulan ko to batiri sanga ay si ay alamo
sa do kala
nyaadi ko ta o bulaji
ado kala nyaadi
kamun ke nyaadi
radio abe wala mo la be mona falaje
ibe la karandirol kala jele
ti talle be radio ko men ka karandirol
ila subjector baby jele baby jele
wala nan ka coco moy fa do ngom metambi kana ngadi ni wolde be ikadum bungo de ko kala maro mo
asototal de
la min mala be kara wala de
bari laftalal ideal on ko inde every year second wala fourth
muna ni ko di ha ko nde ko folle sinila mba ndele sinilo ne ba
mba say mba foke en koto wole fango yen wulindi yalo famo keta bat ñu fana bulata ko ko don me yen nati jambi la min nyanta karana ndel be jiko be nyineka ya bulay kara wulo kono ta kilar ya bambalo yo be bulaje en koto dinni ngoy si ayala le sino la moy radio
wara ka munda kara mo man soro la min nyanta kara si so na regular
la sila le ayala le sino
dal ko korno ko smalo
kilar ya
be ngala ko momo say mi do ni ko no kera
mengi bruce
ndaba ko la da ba rosa no radio ba no bari woro radio ni abe jele ba do ngamra do man dembe buljan dala nyara nyar wo ko fendi mo la la min tayra ba rosa
bara te ku folo ajibe nori nya la bi tamete ku
teku
bari ko do famo ke
ja image nañu ñambol si zol le keje kisgi man si zol no le kafun ka ñowa bari ñambu kino ni mañana ka finde ni nambe ko do la ja
ngalle limbeta de be ñambo do dilanna
ñara nim ko ridin fennat ñara nata
bari famo ke da
ngata bungono tammi bungono ñara ngando ko fele ko ke bar nganda ni pelo la ndija
iyo awa
la bungono bismillah bisu diara
pendulala ye fongo tanka sina dolu tanka koro korota korota
Hi everyone, I am Mr. Babukar Au, your chemistry tutor, and today we will start from the properties of salts. But before that, we will go back to our assessment and then we will try and answer the questions together. And then the previous questions were one, that is number 1A, what is basicity of an acid? Hello everyone, I am Mr. Babukar Au, your usual chemistry tutor, and today our topic of discussion will be based on intermolecular bonding. Our previous lesson we started chemical bonding, and then we are able to divide chemical bonding into two. That is, we said it is divided into interatomic bonding and also intermolecular bonding. We are able to discuss about the interatomic bonding. And now today, we will base our discussion on intermolecular bonding. Now we said intermolecular bonding, this is a weak force of attraction between molecules. A weak force of attraction between what? Molecules. Now if you look at the model on the board or on the screen, we have HCl, one molecule of HCl bonding with another molecule of HCl. Now you can see that in the first molecule of HCl, there's a bond between the hydrogen and the chlorine. So that bond is intra-bond. That bond is containing inside the molecule of HCl. And that type of bond is called covalent bond. You can also see a bond that is represented using a dotted line between one molecule of HCl and another molecule of HCl. And this bond is between the chlorine atom from the first molecule and then the what? Hydrogen atom in the second what? Molecule. That means this bond is existing between what? Molecules. That's why we said that bond there is an example of intermolecular bond. That is intermolecular what? Attraction. But it is what? Weak. So the first bond, where we have hydrogen and chlorine in the first molecule, that bond is inside the molecule. That's why we said that bond is what? Is strong, because it's an example of covalent bond. So covalent bonds are stronger than what? Intermolecular bonds. So if you have covalent bonds that hold molecules together, those molecules, when they want to bond to form maybe series of molecules together, in that case we have what? Intermolecular bond or intermolecular attraction, which is going to be what? Weak. It's not going to be strong as the covalent bonds. And then we have two main examples of intermolecular bonds. And then the first one is called hydrogen bonding. Hydrogen bonding. Then the second one is van der Waals forces of attraction. And then we will go into details to explain what we meant by this hydrogen bonding and also van der Waals forces of attraction. Now before that, let's just have a recap questions based on the what? Intermolecular bond and also the bondings we were discussing in our previous lessons. Now number one, a chemical bond is, we have options. A, an electrostatic force of repulsion, that is A. B, an electrostatic force of attraction. C, a physical connection between objects that are touching. And then finally D, none of the above. So we can crack our brains something like 5 seconds. Now the correct option in this question is letter B, which is a chemical bond is an electrostatic force of attraction. We move to number 2, and number 2 reads, which of the following correctly ranks electrostatic forces from weakest to strongest? That is, we have letter A, covalent bond, ionic bond, intermolecular forces. B, ionic bond, covalent bond, intermolecular forces. C, intermolecular forces, covalent bond, ionic bonds. And D, intermolecular forces, ionic bond, and covalent bonds. So the correct option in this question is letter C, which means intermolecular forces are weaker than covalent bonds, and covalent bonds also are weaker than ionic bonds, which also means ionic bonds are stronger than covalent bonds, and covalent bonds also are stronger than intermolecular forces. Now, number 3, which of the following is pointing to an intermolecular bond? Now we have A, which is pointing an intra bond, that is between the hydrogen and oxygen in the same molecule. We also have B, which is pointing between oxygen and hydrogen from different molecules, that is intermolecular. We also have C, which is pointing between hydrogen and oxygen, which is also intra. And we know intra also is types of what? Or intra is a type of interatomic bond. We also have D, which is pointing between oxygen and hydrogen. And then this oxygen and hydrogen are also found in the same molecule, which means it's a type of what? Intra bond. So the correct option here will be letter B, because B is pointing between oxygen and hydrogen from different molecules. We have number 4, and it reads, the arrow below is pointing to an A, intramolecular bond, B, ionic bond, C, intermolecular bond, D, both A and B, and E, both B and C. And then if you look at the model, the arrow is pointing a bond that is between oxygen atom and hydrogen atom, which is in the same molecule, which means the correct option will be letter A, which is intramolecular bond. Now we move to the types of intermolecular bonding. And then initially we said the first type is called hydrogen bonding. Now hydrogen bonding occurs between a very electronegative atom and a hydrogen atom, covalently bonded to an other very electronegative atom. For example, if you have HCl, that is the initial molecules we have, with an other molecule of what? HCl. So the bond between this chlorine and hydrogen is termed as intermolecular, because the bond is between what? Molecules of HCl. So the bond between hydrogen and chlorine is termed as interatomic, and this one will be intermolecular. But here we want to discuss about the nature of hydrogen bonding, and then we know that hydrogen bonding does not occur in all kinds of molecules. Now, the first thing is hydrogen is the only atom that can take part in hydrogen bonding because of its small size. Now, this statement now is for what? The cation. Now, any bond that is termed as hydrogen bond, there must be what? Hydrogen atom. And the reason here is because the small nature of hydrogen atom. And again, the electronegative atoms that form hydrogen bonds are FON, that is phone. One, we have fluorine, oxygen, and then we have what? Nitrogen. So that is only these three atoms can form hydrogen bond with what? Hydrogen atom itself. Hydrogen must be present, and then when hydrogen is bonding with F, it can form something like HF. When hydrogen is bonding with oxygen, it can form H2O. When hydrogen is bonding with nitrogen, it can form ammonia. So these are the three molecules in which we have hydrogen bond. Now, we use FON, that is FON, that is fluorine, oxygen, and nitrogen, because one, they are very electronegative. That is fluorine, oxygen, and nitrogen. These atoms are very, very what? Electronegative. The second reason is having a very small what? Nuclei. If you draw the bonding of fluorine, oxygen, and nitrogen, you'll come to realize that their nuclei is what? Small. 3. Having a relatively high charge density. High charge density. And high charge density is simply the charge of that element, or the ratio of the charge of that element to its what? Volume. So fluorine is -1, oxygen is -2, and then nitrogen is -3. So these three types of atoms have high charge density. Now, these are the three reasons why these three atoms can react with hydrogen to form a hydrogen bond. Now, we still on the note, hydrogen bonds with fluorine are what? The strongest. This is only applicable when you consider one of the factors, that is the electronegativity of what? Fluorine. Because fluorine is more electronegative than what? Oxygen. Oxygen also is more electronegative than what? Than nitrogen. So if you use the first factor, when fluorine reacts with hydrogen, that molecule will be stronger than when oxygen reacts with hydrogen, and also when nitrogen reacts with what? With hydrogen. But then we will try to explain which of these molecules, that is which of these atoms, when react with hydrogen, is stronger. D. A hydrogen bond can be formed between two molecules when, Roman figure 1, one molecule has a hydrogen atom bonded covalently to a high electronegative atom. That is the first place. If you have your HF, we know that this is one molecule of hydrogen fluoride. So the bond between this hydrogen and this fluorine is called intermolecular, and it's a type of what? Covalent bond. Covalent bond. So when this bonds with what? Another molecule of hydrogen fluoride, now this type of bond will be what? Hydrogen bond, because the bond is inter, and again also is between hydrogen and fluorine, and fluorine is small. Fluorine has what? High charge density, and also the nucleus of fluorine also is what? Is small. And again 2, the other molecule has an atom which is also highly electronegative, small in size, and carries a lone pair of what? of electrons. Now, if you draw the bond of this HF, you'll have something like this. You have here 2 electrons. You have here 1, 2, 3, 4, 5, 6. You see now, they are what? Lone pair electrons. So these lone pair electrons now can easily what? Cause some attraction towards the what? Another electronegative atom. If this is fluorine now, when it is hydrogen now, like this, in this case, we have hydrogen now. So there will be what? This is the hydrogen atom now. There will be what? Attraction between this fluorine and what? This hydrogen. Therefore, they will be able to form what? Hydrogen bond. So this lone pair electron can easily cause what? Attraction. Now we have a model on the board, and the first model there, we have 4 molecules or 5 molecules of water, and then the model is trying to show where the hydrogen bonds are located. Now you see the central molecule, you have oxygen, which is red, and then attached, we have 2 atoms of hydrogen atoms which are attached. Now you see, oxygen is having 2 lone pairs of what? Electrons. So each lone pair of electron is trying to what? Cause attraction to the hydrogen atom on the other what? Water molecule. So therefore at the end, they will be able to form what? Hydrogen bonds. Now in the second molecule, you see, the oxygen now is partially negative, while the hydrogen atoms or the hydrogen there is what? Partially positive. That is the 2 hydrogen atoms. So in the other molecule also, you have oxygen still partially negative, hydrogen atom partially positive, the other hydrogen atom also is partially positive. Now there will be attraction between the partially negative oxygen from one molecule to the partially positive hydrogen in the other what? Molecule. So that there will be what? Force which may lead to what? Attraction. And then this attraction now, because it's between oxygen and hydrogen now, it becomes what? Hydrogen bond. Hydrogen bond. Now we have factors affecting the strength of a hydrogen bond. What can determine the strength of hydrogen bond? How will we know this type of hydrogen bond is stronger than the what? The other type of hydrogen bond. Hydrogen bond. And then the first factor here is electronegativity. Electronegativity. Now, initially we said electronegativity is the ability of an atom to attract an electron towards itself. Now, the more electronegative the atoms, the stronger the hydrogen bonds form. That is, if we have F, we have O, we also have N. We know F, that is fluorine, is more electronegative than oxygen. Oxygen also is more electronegative than what? Nitrogen. So we can say, regarding the first factor now, we can say HF is stronger than what? H2O. H2O also is stronger than what? NH3. But this is just based on the what? First factor. Now the second factor is number of hydrogen atoms formed. That is, the greater the number of intermolecular hydrogen bonds, the stronger the hydrogen bonds form. Now we consider F and what? O. That is fluorine and oxygen. Here we will have HF and here we will have H2O. So the bond in here, if you draw the structure, we will have something like this. See, this fluorine now, this hydrogen. We only have one atom of hydrogen attached to the what? Fluorine. And in this case now, we can have oxygen, we can have here hydrogen, we can also have here what? Hydrogen. Now you see, we have 2 atoms of what? Hydrogen attached to the what? Oxygen. So therefore now, we can say water is stronger than what? HF, because water forms more what? Hydrogen bonds. The third factor is electronic structure of the other atoms. That is the other atoms that is trying to bond with what? With hydrogen. That is trying to what? Attract hydrogen. Now atoms with lone pairs of electrons that can point towards the hydrogen atom of a nearby molecule form stronger hydrogen bonds. That is, if we don't want, now let's compare oxygen and what? And nitrogen. Now here with hydrogen atoms we'll have H2O. With this we will have what? NH3. So if you draw this, we'll have something like this. You have your lone pair of electrons, lone pair of electrons. In this case, you will have 1, 2. You have your single lone pair of electrons. So these two atoms are what? Hydrogen atoms, and these three are what? Hydrogen atoms. This is the nitrogen and this is the oxygen. But there are more lone pair electrons that can what? Point towards, or that can cause attraction towards what? A nearby what? Molecules. And here we have what? A lone pair of electrons, that is a single pair of electrons that can what? That can cause attraction towards what? A nearby molecule. Now therefore we can say this water molecule now will have a stronger hydrogen bond than what? Ammonia, because there are what? More lone pair of electrons in the water molecule than in the what? Ammonia molecule. The fourth factor is bond length. Bond length. Now when the size of the hydrogen bonding forming atom Y is large, then we can say HY bond length will also be what? Large, and weak hydrogen bond will what? Will be formed. For example, if we have, if you want to compare H is bonding with X, H is bonding with what? With Y. You see now? And then we assume X is having 2 cells, and then Y is having what? 1, 2, 3 what? Cells. Now, if Y is bonding with what? With hydrogen, there will be what? Great distance compared to what? When X is reacting with what? With hydrogen, because X is just having 2 cells and Y is having what? 3 cells. So there will be what? A greater distance in HY than in what? HX. So therefore, when these bonds are all, or when they are both what? Hydrogen bonds, we can say that HX will be what? Stronger, and now HY will be what? Weaker, because the larger the distance between the hydrogen and the what? Other atom, the weaker the hydrogen bond form, and you can determine this using the size of the other atoms. Now we have some try questions, and then number 5 reads, which of the following molecules has hydrogen bonding as one of its intermolecular forces? Which of the following molecules has hydrogen bonding as one of its intermolecular forces? Letter A, HF, that is hydrogen fluoride. Letter B, HCl, that is hydrogen chloride. And letter C, HBr, which is hydrogen bromide. D is HI, which is hydrogen iodide. And E, all of the above. So in this case, fluorine is smaller than chlorine, smaller than bromine, smaller than what? Iodine. Because of the electronegative nature of fluorine, and also its high charge density, and also its small nature, will make HF to be what? Hydrogen bond, and then B, C, D, and E will not be what? Hydrogen bonds. Which means the correct option in this question is letter A, which reads HF. Number 6, which of the following molecules has hydrogen bonding as one of its IMFs? And then it's the I stands for inter, the M molecular, and the F forces. That is intermolecular forces. intermolecular forces. We have CH3F, that is methyl fluoride. We also have CH3Cl, which is methyl chloride. We also have C, which is HBr, which is hydrogen bromide. We also have NO2, which is nitrogen 4 oxide, and E says none of the above. Now the correct option in this question is letter A, because it is where you are having fluorine burning with what? With hydrogen atoms. Now, whenever these three elements, that is F, O, N, form, whenever they are reacting with what? With hydrogen, we assume hydrogen bond is taking place. So no other atom apart from these three can form .